All right, so 4.5, number 2. We're talking about dilations again, wrapping up dilations here. And last class on Friday, we just talked about positive dilations, okay, positive scale factors. So we're going to get into negative scale factors today. So what I want you to do is I want you to take these 2 points and I want you to use a scale factor of -1. And I want you to come up with a new ordered pairs. Okay, so do exactly what we did last week. With a scale factor of -1, let's get our new points. Okay, what are our new points going to be here? What's A prime going to be after that scale factor of -1? Okay.
-4.
Okay, -4, -5. Remember, we're just multiplying by that scale factor. Parker? So there are new points. So we have -4, -5 is down here. That's A prime. -2, -7 down here. That's B prime. Throw from there. Okay. Let's think back now to before the quiz. Ignoring the fact that we just did a dilation. And I want you to come up with what other rule, what other transformation would get us from here to here and from here to here. My first and actually, what other transformation is going to get there? Look back at your notes if you need to. All right, so what other type of transformation could this be? Okay. Yeah, this is a 180-degree rotation. I'm taking AB, I'm rotating 180 degrees, and it's landing here. So a scale factor of negative, so a dilation of a negative, really is just a 180-degree rotation. Okay, it's the same exact thing. So I would put that down. Okay, so a negative dilation really is the same thing as a 180-degree rotation. So in terms of dilations, that's the new thing that we're throwing at you today. It's just that negative. But we're still going to do everything the same way we did before. Okay, we're still taking that scale factor. We're still multiplying everything by that scale factor. We just need to understand exactly what's happening in the graph. Okay, I want you to go ahead and get your new ordered pairs here. Multiplying by -1/2. And then we'll look at the visual of exactly what happened. Okay, tell somebody around you what those new ordered pairs are going to be. Okay, so we know we're just multiplying by -1/2. Make sure you're changing the sign on all of these and cutting it in half. Same thing as dividing by -2. So when we do that, what is happening to my figure? It's getting smaller, right? It's getting half as big. Well, what else is happening with that negative? Jackson? It's rotating 180 degrees. So we're taking that original figure. Okay, here's the visual of it. So in that one transformation that we just did with that negative dilation, we did two things. We took this and we rotated it 180 degrees and we shrunk it down by that factor of 1/2. Okay, so this is a dilation. Okay, because we're still going closer to the center of dilation. We are still getting smaller, right? It's on the other side of that center of dilation. So H and H prime are going to match up. You'll notice if I draw those lines in, if I connect those, it's going to go straight through that center of dilation. That's going to be true for G and G prime. That's going to be true for F and F prime, right? It still goes back to that center of dilation. This distance is half of this distance. So that's that thing we talked about scale factor on Friday, where it does both the size of the shape and how far away the shape is. That still applies here, right? To F prime is half the distance as to F. G prime, G, same relationship. Okay, so scale factor still means the same things. It just looks a little different because it's on the other side of the center of dilation. Because it was a negative, because we rotated it that 180 degrees. Okay, so that's a big difference here, is just understanding what it's going to look like. Again, we're still solving it the same way. We're still just going to multiply all of our x's by the scale factor, all of our y's by the scale factor to get those ordered pairs. Okay, you'll be asked to graph on big ideas, of course, on the test on Thursday. It'll just be ordered pairs that we need. Any questions about that? Okay. So beyond just finding our scale factor and beyond just doing this on a coordinate plane, we've got one other type of thing that we need to talk about, and it's not on a coordinate plane. It's more of a real world situation, okay, which is what we're looking at here. We cover up the answers so you don't have answers there. But we're looking at a real world situation involving scale factor. So read it, take a look at it, see what we're talking about. Okay, so we're making our own photo stickers. The original photo, 4x4, stickers 1.1 by 1.1. We want to know what is the scale factor of this dimension. I would like you to find that scale factor. Remember, we cannot have a decimal inside of a fraction. Okay, so I want a fraction. I want the scale factor with no decimals in it. If you haven't yet, tell somebody what the scale factor, what you think the scale factor is here. Or if you're unsure, at least something about this. What do you think it might be? All right, so what do we think here? The scale factor going to be for this? Or how can we set it up or anything about that? Got it?
So you can do like 1.1 over 4.
Okay.
And then change it to 11 over 40. And we can simplify it more.
So there's our scale factor, 11 over 40. Somebody other than Riley, why is it 1.1 over 4? Why is it not 4 over 1.1? Oh, yeah, remember it's always, scale factor is always image over pre-image. And in this case, the new thing, the image, are the stickers. So that's our 1.1. Our pre-image is the 4, that's the original. There you go. So if we want to change this, now that we're talking word problems, if you want to think of the image as being the new and the pre-image as being the original, that might help us out in the word problem. Okay, so it's always new over original. New over old, however you want to think about it. But the new goes on top, the original, the old one goes on bottom. And yeah, we have that 1.1 over 4, and we just talked about this in the warm-up today. All right, multiply top and bottom by 10, move that decimal. We get 11 over 40. Can't simplify that because 11 is prime. We got 11 40. That's the scale factor. Good. When we're doing this, you got to make sure that your units are the same. Okay, if our units were not the same, let's say we were going to a billboard instead, and we're making it into feet, then for our scale factor, we would have to convert either the inches to feet or the feet to inches. When you make a scale factor, okay, the units have to be the same top and bottom. Just make sure on that, okay, you might run into something like that, where they're giving you 2 different units. Make sure they're the same before you create that scale factor. All right, so you're gonna see real world, easy for me to say, like that. But then we are also going to see one other thing, and I apologize if you don't like spiders. Oh, we're looking at a spider. That's gross. All right, so here's the situation that we have. All right, we're using a magnifying glass to look at this giant spider. It says you're using a magnifying glass that shows the image of an object as 6 times the object's actual size. Determine the length of the image of the spider seen through the magnifying glass. Okay, so this 1.5 centimeters, that is in real life how big that spider is. I know sometimes that can be confusing. They would show it through a magnifying glass if they were giving you the magnified version of it. Okay, so this is the original. Super gross that I'm up close to it like this, and it's giant. So 1.5 centimeters is actual real life spider size. They're asking us what's the length of the image going to be through the magnifying glass. So what is it going to look like through the magnifying glass? Okay, this one, I mean, we can do this pretty easily, right? What do we, how, just common sense wise, what would we do to find this answer? Parker? 6 times 1.5, right? We know it's gonna be 6 times bigger, we're gonna multiply it by 6. Okay, we know that. Sometimes if we get confused and we don't know whether we're going to multiply by 6 or divide by 6, okay, depending on which way we're going, let's just talk about it in terms of that scale factor. Okay, when they tell us how many times bigger it's going to be, that is the scale factor. Okay, that is the scale factor, and we said, and I just erased it, but our scale factor is the new over the original. Well, our scale factor is 6, right? It's 6 times bigger, getting 6 times bigger. Scale factor is 6. We're looking for the new version of it, and the original was the 1.5 centimeters. So we can use scale factor to solve these problems out. We don't have to on sometimes, like we all knew that we just multiplied the 1.5 times 6 to get that answer. But we can use scale factor and set up that equation to be able to solve for x. Okay, here we would just multiply both sides by that 1.5 and we've got it. We're looking at 9 centimeters big for the image through the magnifying glass. Now, if they give us the other way, right? Let's say same magnifying glass, 6 times bigger, but now they're telling us that through the magnifying glass, the spider looks like it's 11 centimeters big. Okay, so then that's the, sorry, wrong one. If through the magnifying glass, it looks 11 centimeters big, that's the new, right? That's through the magnifying glass, that's the new version of it. We want to know how big the original one is. I bring this up not because we don't know how to solve it or couldn't figure out how to solve it. I want to remind you of how do we solve something with a variable in the denominator. Everybody remember or know how we get that x to the other side, how we get what x is going to equal here. Like, what do you think? So we would multiply both sides by x. So now I have 6x is equal to 11, but then I still have to get rid of that 6, right? So x is going to be 11/6. The shortcut to this, okay, the shortcut to this, and this is any time that we have a variable in the denominator that we need to solve for, okay? We're going to run into this later in the year too. Anytime the variable we're trying to solve for is in the denominator, just switch it with whatever's on the other side of the equal sign. Just switch it with whatever's over there. So we want to solve for the x that's in the denominator. We're going to switch it. It's going to become x is equal to 11/6. That's a nice shortcut that we can use to solve for the denominator. Okay, switch it with the other side, and we've got it. So we would take 11 divided by 6. We'd have to round it depending on what they're rounding to, or we give it as an exact answer of 11/6 centimeters. Which is a weird number, but we go with it. So those are the two other types of situations that you're going to see other than just in the coordinate plane. Here's your dilation, multiply the numbers. You're going to see your real world. A lot of times it's pictures or pieces of paper that you're enlarging or reducing. And then you're going to see magnifying glass or microscope or something like that where you're enlarging an actual figure. Okay. Always we can set up that scale factor as being that new over the original. Right, or the image over the pre-image, however you want to think about it. Okay. Any questions about it? That's all we have. Okay.